2025 from 15th to 20th December. On the first day, Dr. K. Lavanya Madam, Assistant Professor, Department of Computer Science, Acharya Nagarjuna University, Guntur, delivered a talk on a mathematical key for understanding quantum computing in AI era. On the second day, that is 16th December 2025, Dr. L. Jagannathan Sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, delivered a talk on mathematics of transformers. Okay. Yesterday, that is 17th December 2025, Dr. M. A. Srinivas Garu, Professor Emeritus, Department of Mathematics, JNTU, Hyderabad, delivered a talk on role of mathematics in technology. So more than 500 participants attended yesterday's session. Thank you one and all for your valuable participation in yesterday's session. Okay. Now I request our beloved head of the department, Dr. Kevalan Acharya Sir, to address the gathering for today's session. Sir, please.
So good evening to all. Thank you, sir. Good evening to all. Dear today's resource person, Sri NVRD Kumar Garu, my esteemed faculty members and dear beloved students. We are all gathered here through virtual mode in the fourth day of our international workshop. All of us know that computation skills of mathematics along with the conceptual approaches definitely enrich the students for enhancing their knowledge in multifarious fields. In addition to it, it also helps us to update existing knowledge in the student community and create a deeper interest in various fields of mathematics. I appreciate our students for their active participation and interest towards enhancing their knowledge. Today, our resource person is Sri NVRD Kumar Garu, Senior Faculty Member in Department of General Education, Harjan University College, Emirate of Azman, United Arab Emirates. Sri NVRD Kumar Garu is one of my best and exceptional students in my teaching career. And also, I am truly impressed by his sincerity, hard work, and respectable attitude towards his teachers. His affection for learning and dedication to his studies set him as of the best students. His soft and humble nature further adds to his admirable qualities, making him a joy to mentor and a role model for his peers. Thank you very much, Sri Kumar Garu, for accepting our invitation. Finally, I would like to express my appreciation to all our students for their ongoing enthusiasm and dedication. I am confident that today's session will be a fruitful one and enriching experience, providing valuable insights that are both enjoyable and enlightening. Thank you one and all. Thank you, Kumarji.
Thank you, sir.
Thank you very much, sir, for your valuable message. Today is the fourth day in our 1 week online international workshop. Today's speaker is Sri NVRD Kumar Garu, Senior Faculty, Department of General Education, Harjan University College, Emirate of Azman, United Arab Emirates. And now I request one of our staff organizers, Srimati M. Anita Madam, to present the profound profile of Sri NVRD Kumar Garu.
Good evening to all. I extend a warm welcome to all of you to the 1 week international workshop on mathematics, bridging ideas and innovations. It is my privilege to introduce today's distinguished resource person, Sri NVRD Kumar Garu. Sri NVRD Kumar Garu is a senior faculty member in the Department of General Education at Horizon University College, Emirate of Azman, United Arab Emirates. He completed his MSc in Mathematics at Acharya Nagarjuna University in 2005. After gaining valuable experience in various organizations in India, he joined Brighter Prep Institute Sharjah, UAE in 2018 as a senior mathematics trainer and academic development manager. Subsequently, in 2020, he began his tenure as a senior mathematics instructor and course leader at Skyline University College. In addition to his academic accomplishments, Sri NVRD Kumar Garu has earned multiple certifications, including IC3, Google Certified Educator, and a certificate in Artificial Intelligence. These qualifications enrich his professional portfolio. He is also a member of renowned professional bodies such as the American Mathematical Society, the Indian Mathematical Society, and the Skyline University Community Services Committee. His expertise spans various mathematical disciplines, including SAT Math, IB Math, and UK CAT or BMAT preparation, through which he has assisted countless students in securing admissions to top universities in the UK and USA. His proficiency extends to teaching pre-algebra, algebra, discrete mathematics, calculus, engineering mathematics, business statistics, and forecasting analysis. He is also highly skilled in quantitative research and statistical analysis, bringing outstanding accuracy to his work. Over the past 2 decades, Sri NVRD Kumar Garu has got immense appreciation for his exceptional teaching methods, motivational demeanor, and dedication to student success. His soft-spoken nature, passion for education, and unwavering commitment to the field of mathematics make him an valuable resource and inspiration person to students and educators alike. Thank you, one and all.
Thank you, Anita Madam, for your nice introduction about Sri NVRD Kumar Garu. Now, I hand over the session to Kumar Garu. Kumar sir, please.
Thank you. Thank you for the nice introduction, Acharya sir, and Vijay Sarthi sir and Anita ma'am. Thank you so much. I'll try to meet your expectations, as every time I say. Thank you. Thank you so much. First of all, good morning to everyone. Sorry, good afternoon to everyone. I mean, it is afternoon for me here, though I think it's evening for you. So, thank you so much for attending this workshop. So, what I'm going to do today is, I'm not. It is not that I'm going to present something, because most of the things you already know. It is. I prefer it should be just like a discussion. What on the latest topics of mathematics and its applications. Now, when it comes to our topic today, it is on mathematics behind data science. That is what the primary thing. So first, I'm expecting at least a few people to answer my questions so that I can start my lecture or presentation or seminar, whatever you want to call it as. Okay, so my first question, I'm going to ask you a couple of questions.
Kumar Garu. Sorry.
Yes, sir.
Actually, the audience are muted for the connection of the program in a disciplined way. We have muted all the parts. So, please,
no problem.
Thank you.
Okay, sorry. Okay, so as per the protocol designed in the in this workshop or seminar, so I'm going to present a few informative things for you. Hope you will enjoy and you will get some benefit out of that. So let me share my presentation first, so that we can have is my presentation. Can you see my presentation?
Yes, it is visible. You can maximize it a little bit.
Okay, sir. Thank you.
Okay, nice.
Yeah, right. So, good afternoon, everybody. So, this is what our topic today. This is mathematics behind data science, the secret engine of today's tech innovations. So, as you all are pursuing your bachelor's in engineering, I'm sure some of you or most of you are pursuing math, and maybe if any third or fourth year students are there, they might have already pursued the mathematics course of engineering. Now, when it comes to the mathematics behind data science, so there is a straight connection between math and data science. So though the word data science is new for most of us, and we are hearing this word data science from the last 10 to 15 years, but uh, when it comes to the relation between math and data science, math is the core pillar of data science. Now, what is data science? Data science is a technical subject, or you can say a pure uh, object-oriented course, which will help the businesses, industries, people like scientists, educators, students throughout the world to take optimistic decisions by using different mathematical and statistical tools. Now, why companies these days are more depends on mathematical tools and statistical tools? Whatever you are seeing today, I mean, I'm sure all of you are using mobiles. Excuse me. So when you are using your mobile, or when you're watching something on your television, or when you are like going from one movie to other movie in any of the OTT platforms, you will see like your preferred choice, and you stopped in this show yesterday. So this is what that particular platform is collecting your data. Means what you are doing, what you are searching, what you are watching, what you're preferring, everything is being tracked by your device. So the subject data science itself is a combination of mathematics, statistics, and computer science. So the main objective of data science is to take optimistic decisions to improve the quality of business. Have we ever imagined, like 10 years back, that we are going to watch all the movies by sitting in the sofa of our, at the comfort of our home? No. But it is happening today. It is just because of the evaluation of technology. Technology needs more support from different courses of sciences. So, especially when it comes to the data science, as I already told you just now, here we are going to use different mathematical tools, different statistical tools, combining with the programming languages of computer science like Python, Pega software, etc., etc. Now, what I'm going to just discuss today is how the topics, what you are learning today, and what you are practicing in your first and second year courses. And I mean, as I already told you, if anyone is in the third year or fourth year, you might have already did these courses. So I'm sure all of you are studying the courses like linear algebra, statistics, calculus 1, calculus 2, um, in your first or second year of engineering. They're not just like, a course is what you have to pass to proceed to the next year or the next semester. If you look at each and every course, there is an in-depth, invisible algorithm in each and every subject, what you are doing now. So I'm just proceeding with 3 to 4 courses, what you are doing or what you already did. Those are linear algebra, statistics, and calculus. So I'm going to discuss, the flow of this lecture is like this. First, I'm going to explain you, or I'm going to discuss. I think it's sorry to use the word explain, because I'm not trying to explain you. I'm trying to discuss the importance of these courses in different industries. So you all know what is linear algebra. You all know what is statistics, what is calculus. So the first phase of this lecture is I'm going to show you how linear algebra, statistics, and calculus will be very much useful, and after that, how these things will be used in data science. And when it comes to the second phase, I'm going to take 1 or 2 examples what you're familiar with, and I'm going to discuss the application of these things in those areas. Now, if you look at my presentation here, uh, it says how linear algebra, statistics, calculus, and power the applications you use, okay, every day. Now, if you see the picture, you will see different mathematical diagrams, which is there is a graph here, and there is a graph here. So the difference between this is like a sine wave, and this is like a traditional graph theory which has nodes, edges, and everything. And here you have all the calculus symbols and so on. So the main objective of having this picture is I just wanted to tell you what you are learning is not a mere an eligibility course. You're doing really a great job. So all you need to do here is you just have to understand how these subjects will affect some of our daily life applications, what we are using. Now, the mathematics behind data science, powering smarter decisions in technology. As I told you, every technological tool what we are using has a definite and defined algorithm, and that algorithm is based on the mathematical functions which are primarily used to define that algorithm. And it is not related to one particular industry, it is related to each and every industry and every scientific form. Now, this workshop, what we are going to do is we're going to discuss and discover how the mathematical principles transform the raw data into actionable insights that drive technological innovation and strategic decision making across industries. I just wanted to add one example here. When you're trying to buy something in Amazon, uh, have you ever observed how many items you add? It says, okay, you got 20% off, you got this much discount, but the price will never change. But the price will never change. So that is one kind of tool that Amazon is using. And when it comes to the here, there is a word called raw data. Raw data means usually when companies are trying to promote something or promote a product, they will have huge sets of data from different kinds of users. That is called the raw data. And the first stage in this, using this data is cleaning the data. So now, let me go through the next one. Now, why the math matters in data science? Number one, the foundation of math, because without math, we will not be able to model any business or any problem. So any business problem, the solution process, the first phase of the solution process is making a suitable model for that problem. And then we will try to put different variables and we will try to use different variables to solve that particular mathematical model. And when we are modeling a specific situation, the main tools what we use in mathematics is, I mean, at a basic level, we will use geometry, and at a little bit of advanced levels, linear algebra, probability, statistics, calculus, optimization, and information theory to solve the real world problems. Well, when it comes to the linear algebra, I'll just try to make it very simple. When you have an equation like y is equal to mx plus b, there you are dealing with one dependent variable and one independent variable. But if you have two set of equations like uh, 2x plus 3y is equal to 12 and 5x minus 6y is equal to 25, you're going to find the values of x and y. Just imagine you have 1,000 variables and 1,000 equations. So our human effort is not sufficient to solve these kind of equations. So there we need the help of a machine, and the main area of math which we are going to use in solving a huge set of equations, that is called machine learning. When we are going to use machine learning techniques in establishing or in finding solutions for any specific problems, the main tool which we're going to use there is linear algebra. And when it comes to the modeling, and once you complete the model, and once you're going to get the values, and if you're trying to optimize the business, then there we are going to use the tools like probability, statistics. And when it comes to calculus and information theory, these are also very much useful. And the next one is the main reason why math is really matters in data science is because of the patterns what we use in math. The mathematical tools they really uncover the hidden patterns in massive data sets. I'm not talking about a data set of like 10 variables or 100 variables, like millions of variables, like millions of variables and millions of rows and millions of columns. A data set means it has many independent variables in the form of rows and columns. So massive data sets can be patronized using different tools of math. And once the data is collected, and we will clean the data and we will use different tools of mathematics to get an optimistic decision that we call it as data driven decisions in the complex technological environments. I think some people are raising their hands. I really appreciate that. But as already Dr. Vijay said, told that it is disabled. So I think I'll not be able to attend any of your questions. Now, when it comes to the linear algebra, it is primarily it is primarily called as the language of data. And especially when it comes to the linear algebra, I'm sure all of you are dealing with matrices like rows and columns. We know that A, B, C, D, 1, 0, 0, 1, identity matrix, and these things. So when it comes to matrices, at a higher level, at industrial level, and the complex technological environments, like if you take any big tech giants like Google, Meta, Microsoft, anywhere, no, they use linear algebra every single minute. So especially PCA, which is the principal component analysis, and because it is really useful in reducing the dimensionality and recommending the engine algorithms, image and signal processing, natural language processing models. And linear algebra is very much useful there, especially the matrices and their applications. Now, when it comes to probability and statistics, well, the best application of probability and statistics is like stock markets. Well, I'm not talking about like how you will invest and how you will get profits, but it's a science. These days, there is one area in stock markets called quantitative finance. So quantitative finance is a combination of both quantitative subjects, which means mathematics, statistics, and Python and different programming languages together with the finance. So their probability models are very much useful because probability models forecast the future outcomes. They assess risks and they quantify the uncertainty in decision-making process. And in the statistical methods, mainly we use regression analysis, hypothesis testing, and these inferential statistics. They enable the robust and data-driven predictions. So especially the concept of regression analysis is very, very important. It is directly related to forecasting. So forecasting means, let me simplify that in 2 to 3 sentences. Uh, just imagine you're going to, let's say, you're going to admit, or you're going to admit in one of the university, and you want to find out what is the relation between the fee you pay and your starting salary once you complete the course. So what you're going to do there, you're going to do modeling. So how we will collect the data here, what we will do is, okay, we will collect the data related to 30 or 35 students if you want to work in using a smaller model. So we will collect the data of 30 students and we will say how much you paid for the entire course and what will be your starting salary. So if you take one student, maybe one student might paid at $50,000 for one course, like 1 year or 2 year course, and his starting salary is $90,000 per annum, what I'm talking about. So if you can collect these models, if you can collect the data of like 30 to 35 students, you will have how much each student paid for the course and what will be his starting salary. So if you can create a model using this, taking the tuition fees is as X and his starting salary as Y, you can make a model with a simple equation like Y is equal to mx plus b, where X represents the tuition fee and Y represents the starting salary. There, the value of M represents the gradient, which means what is the rate of change depends on the amount of fee. So if you have this data, and let's say your course is $100,000. So if you put $100,000 in the value of X, you will get what is your starting salary. This is like a forecasting. So, but you have to understand that when it comes to the forecasting, it is not guaranteed that 100% is going to happen and 100% your result is true. So what you have to understand is forecasting is just, it gives you a prediction up to a maximum accurate level. So statistical methods are very much useful there. And after that, business impact. When it comes to the impact of these things on business, it is completely depends on the mathematical precision and the validated insights. So some people might have asked a question, okay, if I have a data set of 100 X and 100 Y, and I make a model, and I'm going to get a value for some specific value of X, is it 100% correct? We cannot say, because the name itself is saying you're forecasting it. You are estimating the value. So when it comes to the estimation, you need to understand it has a good amount of probability to be an accurate value. At the same time, there is a possibility that that estimate might not work. It all depends on the quality of data you take. The quality of data means, as I told you, the value and the quality of data means the numbers you're collecting should be accurate. Sometimes, we will get the weather predictions. Maybe tomorrow and day after tomorrow, it might rain. How they get to know? Because the meteorological department collects the data each and every hour, and they will say, based on these statistics, based on this data, it may rain. It's not that, don't think that they are saying 100% it is going to. They say it may rain, not 100%. When I say it may rain, it may rain, it may not rain as well. So you need to understand the difference between probabilistic probability models and accurate results. So when you're going to use any statistical tools, please keep in mind they are predictions only. They give you a good estimate. So you have to understand that whether you're going to accept those decisions or not. Especially when you see the e-commerce platforms, they use multiple regression models to forecast sales trends, optimize inventory levels, and minimize waste, turning statistical insights into millions in cost savings. As I just told the example of Amazon, they use different like different kind of trends and data. Like, for example, if you want to buy a mobile, just go and filter it using like 4 stars or more. So you will get all the mobile models with 4-star feedback. And again, if you try to filter, you will see many variables. You want to filter it by brand, or you want to filter it by quality, you want to filter it by the capacity of RAM, or you want to filter it by memory, and so on. It gives you so many parameters. So those are the variables I'm talking about when you're going to use probability and statistics. And when you're learning calculus, do you know calculus has a huge relationship with the optimization? Maybe at the college level, you might not see that type of uh, overview, or that type of you can say focus. But calculus is one of the most important things in machine learning, like, because it tells you how the derivatives and gradients measures, and how it changes the input and affects the model output, and forming the mathematical basis for learning algorithms. So if you want to write an algorithm, first of all, you have to decide the variables. When you decide the variables, you have to understand the change in the variables. Means, like, how an x is changing y, or how an a is changing b, how a p is changing q. You need to understand the difference between variables. And when it comes to the optimization algorithms, they use calculus to navigate the error landscape, finding the path that minimizes prediction mistakes. And recently, I have attended one seminar in one of the university in Dubai. One professor told me how he is using calculus, especially the concept of gradient and the error landscape, in making the solar panels because he's that going to install in a desert. So it was quite interesting. So don't think you're learning calculus only to understand the difference between integration and differentiation. It has a lot of applications. And the other one is parameter tuning. Fine tune millions of model parameters simultaneously to maximize accuracy and generalization across diverse data sets. Simply speaking, we are living in a data driven world. What you are doing, what you are searching, where you are applying, and everything, where you are spending, on what you are spending, where you want to go, which movie you want to see, which city you want to visit, which train you want to catch up. Everything is tracked using your device. So when you take only yourself, the data is huge. Just imagine how many the amount of population on the total planet. So, especially when it comes to the deep learning models, they apply the chain rule. We know the chain rule in calculus to efficiently learn from vast amounts of data, powering breakthrough the AI application. So, this method is called the back propagation. So, this is how we're going to use different topics of math in the world of business and technology. Now, when it comes to the data science, there is a rule called the 37% rule. The 37% rule provides a mathematically proven strategy for making optimal decisions when you can't go back. So, how it works is like sample approximately 37% of available options to establish a baseline, then select the next option that exceeds your best observed choice. So it is again one of the best decision making approach. So these are mainly used in the hiring decisions, product selection, resource allocation, like that. Now, overall, when it comes to data science and action, from theory to innovation, there are a lot of applications, lot of applications. Even if you take in our country, how much data is available, it's huge. The data is in then the vehicle models, healthcare AI, and fintech, especially when it comes to the healthcare AI, the AI-powered diagnostic systems leverage statistical inference. Now, if you see, I mean, still in India, we have only like 10 to 15% of the people have health insurance. Um, how the health insurance there is one topic like how the health insurance companies use the data of diagnostic results of different categories of people in framing their policies. You just imagine, I'm going to minimize the data set here. Let's say an insurance company wants to introduce a new policy, but it got to know the diagnostic data, which says 90% of the people are suffering with um, a disease. So definitely, when they're framing the policy of that policy, that insurance plan, they will definitely remove that disease because it's very simple. If they add that, they're going to pay to 90% of the people, which the insurance companies will not take any risk. So the AI-powered diagnostic systems leverage these statistical inference and optimization algorithms to analyze medical imaging and accuracy rates that uh, ex- uh, rival expert physicians. So this is how we use different sets of data. I mean, I can't even tell you like how much the data is, the size of the data. It's huge. You can say sky is the limit. Just imagine in our country, there are nearly 50 to 60 crores of credit cards out there and debit cards together are there. If you look at one statement, we have nearly one statement we have per month. We have nearly like minimum 30 and maximum 150 transactions. You just multiply the 60 crores with 30 to a minimum level and the 60 crores to 150 to a maximum level. You will see that particular data only in financial sector. That too related to debit cards and credit cards. So that is what the fintech is going to say here. The fintech platforms use sophisticated mathematical models to detect fraudulent transactions in real time and optimize investment portfolios for maximum risk-adjusted returns. So this is one of the emerging area, which is a fintech. Okay, and so that's how the data will be really useful from theory to invent new things. Now, but the main, I mean, the time-taking process in data science is cleaning the data, because sometimes what the data we get, not sometimes, most of the times, it is not in a proper format. So when it is not in a proper format, companies spend most of the time on cleaning the data. And even that is what the job of a software engineer first they do is, if anyone is working on the data sets, the most of the time they spent on data cleaning. That's why the majority of data science work involves in preparation and quality assurance. It solely depends on how good qualitative data you have. If you have qualitative data, if you have a good qualitative data, obviously you can maximize the gain and efficiency of the gain. So the mathematical algorithms accelerate data processing compared to manual methods. Okay, and the statistical models identify outliers and errors with exceptional accuracy. It all depends on how good, how qualitative your data is. Now, when it comes to the mathematical solutions in the data science, the statistical algorithms identify anomalies and missing values automatically. And matrix operations enable efficient feature engineering at scale. And the information theory guides optimal data compression strategies. And when it comes to the practical tools, like the modern data libraries like NumPy, Pandas, and SciPy, these are implementing mathematical principles for scalable data processing, turning hours of manual work into seconds of computation. Before Python and R, people used to rely more on SAS and SPSS. And even before that, I mean, the starting one is Excel and Excel programming, and after that, SPSS, which is mainly used in research, and after that, SAS. Now, with Python, what we have today, the work became so smooth and faster. So this is what the power of data science tools. Now, what will be the future trends? How math is going to affect the future trends and the next generation technologies? And I'm sure we all know, especially in Andhra Pradesh, we all are hearing the quantum computing. The quantum algorithms leverage advanced linear algebra and probability theory to solve problems exponentially faster than classical computers, uh, promising breakthroughs in cryptography, drug discovery and optimization, and explainable AI. Because the artificial intelligence is it's a combination of both like machine learning, deep learning, data science, and different mathematical tools. Okay, and the mathematical frameworks make black box AI models transparent and interpretable using techniques from game theory and linear models to explain complex decisions to stakeholders and regulators. Now, when it comes to the next emerging area is sustainable computing. Why sustainable computing is these days, most of the countries on the planet, they are facing the problem of e-waste. Like, if you want me to put it in a simple way, like once upon a time, we used to use the huge desktops with CPU and with a big wire and a lengthy wire. Now we are using laptops and tablets. So as the size decreases, obviously, the wastage of materials what we spent on different instruments previously being reduced. So this is one result of sustainability, and the companies are working more on sustainable computing. Means they want to decrease the size of the devices what we are using now to the next level, so that the wastage of materials will be less. So for that, the optimization techniques minimize energy consumption in data centers and air training, combining mathematical efficiency with environmental responsibility for green technology innovation. Why I'm saying this is the green technology innovation is it's a highly reputed emerging area now because when we used to use the first generation and second generation mobiles, we used to have big devices. Now, because of the revolution in the chip designing, in one chip, if you see, there are lakhs of mathematical codes will be there. So as the quality of the chip is increasing, definitely the size of the device what you're going to use will decrease. So it is not a work of one day or 1 week or 1 month. So companies keep working on how we can store a huge amount of data in a very like a minute chips so that the size of the device will come down. When the size of the device will come down, obviously the materials what the companies use to make these devices will be reduced. So when the materials, obviously, what are the materials that we use in plastic, lithium, and different kind of materials we use? When the size is decreased, obviously, uh, the consumption of those materials will come down. That is what the green technology innovation. All this happens only when the making of chips, chip designing, and hardware technology happens, and that will happen only through mathematical modeling and how they're going to uh, keep or they're going to store huge amount of data in a very small, minute chips. And this is how we have to understand this. Now, when it comes to if you look at the math to unlock the data science potential, mathematics is the practical engine behind smarter, faster, and more reliable decisions that transform businesses and lives. Uh, that is how everything works. You name whatever the device you're using, whatever the convenience you have today is definitely because of the technological advance and the mechanical advance. All those things happen because of the research and immense potential of mathematics. Now, it is innovation catalyst. Mastering mathematical foundations empowers breakthrough innovation across industries, from tech startups to global enterprises. Now, these days, if you look at everywhere, they're asking you, last week, I spoke to one of my ex-colleagues. He is an artificial intelligence expert. So we had a long discussion of 1 hour on a concept called logistic regression. He is working with one of the big companies in Bangalore. So we had a long discussion on one topic called logistic regression. He was saying we are using this concept of logistic regression in a huge scale, like nearly 100 to 100 AI engineers are working on logistic regression because they are working on a transportation project. So this is how the math, the course or subject math will affect your lives. Maybe you might think that, okay, once I complete my bachelor's, I'll learn one language and I'll end up my journey in one of the software companies. But do remember that without understanding the basic mathematical foundations and without having a decent expertise in mathematical concepts, it will be very difficult for you to engage yourself with uh, any of the career programs. Now, the future belongs to those who harness the mathematical principles to transform the raw data into impactful strategic decisions. So that's you need to understand how data science is influencing our lives. That's how you will create interest, and that's how you'll start working on that. Okay. Now, if you see, look at this. Every communication channel what we are using, there is a hidden mathematical universe. Every tap, every swipe, and every click is powered by the invisible mathematical engines working at the speed of light. Uh, so we can't even imagine like how it works. So you need to understand the key thing And the core area of all the technological advancements is mathematics. Now, if you see, every time you stream a movie and if you search for a flight or check your bank account, just understand that sophisticated mathematical algorithms are working invisibly behind the interface. These equations these sets process millions of data points. So if you see here, there are some graphs. You just imagine this is not even 0.01%. All the mathematical concepts will be used uniformly in each and every technological advancement, from calculus to linear algebra to graph theory to group theory to statistics to matrices to conditional probability to optimization. Everything, these equations process millions of data points in milliseconds, transforming the raw numbers into personalized experiences. So you have to understand one thing: every data science and every mathematical tool uh, will progress only when how fast they can clean the data and quickly how quickly they can analyze the data, because cleaning, analyzing, and decision making are the three important steps in the world of data. So what you have to understand is, for all these, the core thing is the mathematics powering our digital world represents humanity's greatest invisible infrastructure. I mean, everything, you name it, in everything, from the mobile, from the desktop, from the computer, and whatever you're doing, everything is directly or indirectly related to mathematics and the data science today. Now, for example, I mean, if you see, uh, I'm just having, I took one or two examples here. We all watch Netflix, right? So um, when once we log into the Netflix, it will suggest based on your experiences, based on your preferences. The core algorithm of Netflix recommendation engine is linear algebra and PCA, as I told you, principal component analysis, where they create different kind of data sets using matrices, your preferences, and other people preferences, and the whole or the all people who are watching that particular show or movie or a series. So Netflix is one of the best example. Uh, it is often called as the search engine and the recommendation engine algorithm of Netflix knows you better than you know yourself. So you might not know about yourself, but Netflix knows about you. The recommendation engine analyzes your viewing history, it pause points, rewatch patterns, and even time of day preferences. Suppose if you're watching one show, or if you're watching like action shows on Saturdays, so the moment you log in on Saturday, you will see some action related show. Or if you're watching some psychological thrillers on a Sunday, if you the moment you log into Netflix on Sunday, it will show you, or it will pop up those series, movies, or any other shows related to the psychological thrillers. So that's how they know. Like especially the topic here called pause points. Suppose you're watching something and you pause it because you didn't like the flow. It will catch that, okay, you paused it somewhere. Okay. And so all this is based on, they use one thing called the matrix factorization and collaborative filtering. This algorithm identifies the latent features in content and matches them to your unique taste profile. So for every person who is watching a show or a movie or a series, they will have a specific data, and they group the data based on the choices. They group the data based on the area. They group the data based on the country. Like for example, whatever the series is and whatever the shows that you are watching in India, I'm not able to watch all the shows because all of them because when it when it comes to the grouping of data based on the country, uh, some of the shows are not accepted here. So that's how that's fast that this recommendation engine will work. So as I told you, it uses the matrix factorization and collaborative filtering, and the algorithm identifies latent features in content and matches them to your unique taste profile. So for every viewer who is watching, they will create a unique taste profile. So your preferences could be different, and my preferences could be different, and some other person's preferences could be different. So when they're making something like this, they will work on each and every person, and they will store that respective data. They will store that specific areas preferences. Maybe like usually there is a perception that most of the Indians we like action-oriented shows and psychological thrillers. Maybe in other countries, when you take the European countries, they prefer more of like artistic shows or artistic movies or something. So it grouped each and everything using matrix factorization. It doesn't just track what you watch; it understands why you watch it and predicting your preferences with accuracy. So that's how they work. When any organization or any system wants to collect data in this way, you will have a huge data sets with different subsets, like countries. So maybe the first thing they do is like the data can be categorized based on country, and again area, and again based on the age group preferences. Because once we subscribe to any OTT, we will create profiles, right? So based on that, it will ask you like, what is your age? Your age is 10 to 15 years or 20 to 25 years, like that. So again, a subsection of data, a huge data sets. So data is something unimaginable. Like if you want to go to any restaurant, you will see the feedbacks and you will see the ratings of that restaurant on a grading of 5. If you see like it's a 4.7, how that 4.7 out of 5 will come? Just imagine. Let's say you want to watch or you want to go to a restaurant and you want to go to a restaurant which has a 4.5 plus rating. How that 4.5, it is not just like a number 4.5 out of 5. May If you check on Google, you will see in the bracket like 1,750 reviews. So 1,750 people who visited that restaurant before, they gave the feedback. Feedback is not just a number, right? So if a person is giving a feedback means obviously there is a different set of questionnaires there. How you felt about the ambience, the food is good or not, how you rate the staff members, how you rate the quality of food, how you rate the price. So there is a set of questions. So which means the moment you see 1750 reviews, it's not like one question. 1750 multiply, I'm just giving a random number like 6, which means you're having 11,000 plus answers. Again, all these 11,000 plus answers will be categorized into groups, means all the 1750 people's feedback on taste, all the 1750 people's feedback on ambience, all the 1750 people feedback on staff behavior, all the 1750 people feedback on the arrangements of restaurant, and so on. So for each and everything, they give the weight, and for everything, they calculate on a scale of 5. And finally, the average of all these on a scale of 5 will give you that 4.7. So that's how the feedback system also works. I'm just trying to give a random example to you. Like 4.7 out of 5, the moment we see, oh, this is a great restaurant, good restaurant, let's visit this. So behind the 4.7, there is a huge mechanism works like this. So I'm talking about only one restaurant. How many restaurants are there we have? How many hotels are there? So when we are talking about these things, it the topic will keep going on. So just imagine about Netflix. It has its operations in more than 150 plus countries. So imagine the kind of data that they collect, the kind of data that they store, the kind of data that they will use, the kind of preferences that they know. So imagine if more people are watching action-oriented shows, then they will understand. Okay, we have to buy only action-oriented shows. And not only that, when you subscribe to any OTT, initially they will ask you one question: give your preferences, comedy, thriller, psychological thriller, and sports dramas, and action thrillers like that. So if all subscribers started giving these preferences, they will get to know which show has more demand. So based on that, they will buy the show and they will do the business. That's how OTT works. Um, Still, some of the people are raising their hands. I really appreciate your enthusiasm, but um, it's not possible for me to give the answers to you because you're restricted. So you have to understand like how mathematics is useful in all these things. Now, so when you look at, as just now I told you about the mathematical mastery in the entertainment related to Netflix. Netflix usually leverages sophisticated mathematical models. Just now, as we discussed, one of them is the SVD, which we call it as singular value decomposition, matrix factorization, collaborative filtering algorithms to analyze 230 plus million users. Oh my God, 230 plus million users, which means approximately 24 crores of people throughout the world, and viewing patterns and deliver personalized content recommendations. So all these are the mathematical tools. So when it comes to the SVD, the singular value decomposition algorithm, it breaks down uses as matrices into latent factors and revealing hidden patterns and viewing preferences with 95% accuracy improvement. So as I told you, every user detail will be collected, every user's preferences will be stored, and based on that only, it do the Netflix does business. Now, when it comes to the collaborative filtering, uh, in this, one of the tool used is advanced matrix operations. They analyze similarity patterns. They're processing billions of interactions to predict viewing preferences and optimize content placement. Just now, I told you, if more people watch action-oriented shows, obviously Netflix buys more action-oriented shows only. If more people prefer to watch psychological thrillers, obviously it buys psychological thrillers only. So all these details, information, and huge data sets, they will form a model, and the more effective model and the solution to that model is will be done using a deep learning model. And in this deep learning model, the neural networks are more important. It is one of the subjects and one of the techniques in math. The neural network combine demographic data, viewing history, and temporal patterns using gradient descent. Again, see here, gradient descent means calculus. And all these things will be used for optimization. If you ask me, uh, like optimization means in one sentence, minimizing the expenses and maximizing the profit. That is the main objective of any business. So, optimization to enhance recommendation precision. Recommendation precision means, suppose if I'm watching some show, I should be able to or Netflix should be able to suggest a proper and a perfect choice as per my interest. That is more important. So that's how. So we all know Netflix as an OTT, but behind its operations, there is a huge mathematical model which involves math, statistics, and computer science. It's a perfect data science model. So that is the reason I took this as a first example. Now, I'm just moving to the second example. And before that, see, this is how the algorithm performance metrics has to be designed. So user engagement, content discovery, retention rate, recommendation accuracy, and revenue impact. So revenue, see here, the blue color one representing pre-algorithm, and the green one is post-SVD implementation. I'm repeating SVD already, I told you, singular value decomposition. So before using this algorithm, the user engagement here is like 60 million or something. And after the post-SVD implementation, post-SVD algorithm implementation, the user engagement has been increased to the next level. And content discovery as well. Similarly, retention rate. See here, it was like around 70 million or something. And after that, using that algorithm, it crossed 80. And similarly, recommendation accuracy has also been increased. And the revenue impact. Obviously, see why any company does all these things simply for the last one, revenue impact. Maybe you might think why we have to think about the revenue. There is no business, no company on the planet which can neglect revenue. Everything is based on the impact on revenue, operations, technology, and recruitment of people in any particular company, any company for that matter, is only one thing will be important, the revenue impact. So how this revenue impact will be impacted, it is showing very clearly here. See here, the mathematical optimization increased user engagement by 35% through personalized recommendations and improved content discovery algorithms. So similarly, revenue optimization. So Netflix is doing all this. Why Netflix is implementing this algorithm is because all these categories have been increased because of the increment of these categories, the revenue is also impacted and it also reached almost 100. I mean, not exactly 100, near to 100. So that the implementation of that algorithm has been successful. So this is how any companies works. When they want to improve the services, they will make different uh, data sets and how each and every category has been implemented and improved because of the adoption of that particular strategy or that particular implementation of algorithm or something. So this is how Netflix, you know, the revenue of the Netflix has been impacted because of the usage of SVD algorithm. So this is a small information for you. So this is how the mathematical thing is here. So when we open our Netflix like interface, this is how it looks like. So the core formula is this: the SVD prediction is computed as. So this is the mathematical formula here, where mu represents the global average rating. So once we click on any show, it will show us like 5.8 out of 10, or it will say 6.9. So that is called the global average rating for that particular show. And not only that, the moment you click on, you open the Netflix. I'm talking about only Netflix here. It says number one in India today, number one in UAE today, number one in UK today, which means the people in that particular region, they're preferring to watch that particular show here. That is what you have to understand. So the BU represents the user bias term, and BI represents item bias term, and QI latent factor interaction, and the implicit feedback component. These are this is how it is defined. It is defined. The incorporating implicit interactions from user behavior means views and clicks. Sometimes you will click the show and you will look at the rating and you will go back because you will come to an opinion that okay, it's only 5.6, which means 5.6 out of 10. So it is not that quite interesting. So let's move to another one. So you'll go back. So that is called a click. A view means Sometimes if the show is 2 hours, we will watch only 1.5 hour and we will not watch the rest of the time. Netflix calculate that also. And sometimes you will watch a 2 hour show in 1 hour. I mean, I do that occasionally. So it understands that it is moving very fast and the scrolling very fast because there is a lot of lag in between the show. So they calculate these things also. So they try to normalize the sum of secondary factors for the rated items and effectively expanding the user representation beyond explicit ratings. So obviously, how Netflix get the money? The more people watch the shows or movies, they will get the money. So otherwise, there is no point that they buy. Okay, and see, this is what the statement of Netflix. We save $1 billion annually through our recommendation algorithm. $1 billion is a huge amount, right? It's almost like 9,000 crores plus. This massive cost saving comes from retention. Subscribers stay longer when content recommendations match their tastes. So the algorithm reduces churn by 80%, preventing users from canceling due to inability to find content. Sometimes we take only for a month or for 2 months. So the moment your subscription is over, it will show you that you got an offer like this, right? So they always try to use this algorithm and prevent users from canceling due to inability to find content. So if you don't find the content what you like, obviously you will go for a cancellation. So behind the scenes, a sophisticated matrix factorization process, the 300 billion events daily, turning viewing data into personalized experiences that keep viewers engaged. 300 billion events, guys, just try to imagine how big number it is, 300 billion. So just 300 followed by 9 zeros. So that's how this algorithm help Netflix to engage with customers in a more uniform. If you look at these graphs and so on, I'm sure Vijay Services will be very happy because he taught me graph theory. So all these are graphs. So how it creates uh, different data sets and how those data sets are internally connected and how this algorithm of linear algebra helps one company to save $1 billion. That is the power of math. So I'm going to take another example here. There is another one, Skyscanner. I'm sure most of you know it. Otherwise, I'll tell you. So Skyscanner is just like um, an online tool which throughout the world people use it to book the flights from one place to other place. Um, Everybody says Skyscanner will give the better offers. Uh, so it's just like Make My Trip. Okay. Uh, but Skyscanner is it's a worldwide application. So when you're trying to find out a flight from one place to another place, it will give you different options. I mean, you will be amazed. I mean, if anyone wants to try, you can try Skyscanner. Try to check a flight from, let's say, Vijayawada to Singapore or Hyderabad to London. Now, then you will get n number of flights. Based on that flights you will choose. Now, how you will choose once you open an application, how you will book a flight. Um, there are different options. Number one, you need to give the origin, destination, date, and how many passengers are working, and are you comfortable with changing of dates or not. And underneath, you will have something called you want to direct flights. You are okay with one stop. One stop means, like, for example, if I have to fly from Hyderabad to UK, maybe I might go from Hyderabad to Mumbai and I will wait there for 5 hours. And again, the connecting flight will be there. That is one stop. So one stop or two stops or three stops or more. So if you give an option like, no, I don't want anything. I want only direct flights. So out of the 100 flights it appears, obviously, when you say direct flight, only the direct flights will come. And again, in that, you can shortlist them based on your departure time. Suppose if you want to travel only from, you want to board the flight between 6 a.m. to 12 p.m., you can give the time. If you want to board the flight from 12 p.m. to 6 p.m., you can give the time. Or 6 p.m. to 12 a.m., you can give the time. So this is a data set. So like this, every single day, millions of people will search Skyscanner. So this is what the algorithm it uses. It treats each and every point, each and every origin and destination as points, like vertices. In the terms of graph theory, we can say graph theory is important sub topic of math, like vertices. And the connection between the two places is edges. So it makes everything as like G is equal to VE, which means V is the set of vertices and E is the set of edges. And then it starts working on the most feasible algorithm. So every flight search triggers a cascade of optimization algorithms. The moment you click search indirectly, I mean, on the back of the screen, like many algorithms will work. The optimization algorithms means sometimes you don't want to spend more than 25,000 rupees, let's say, to book a flight from Hyderabad to UK. Okay. Or let's say 50,000. So you can give the budget option as like maximum price will be 50,000 rupees. Okay. And uh, the system builds a massive graph of possible routes, applies dynamic programming to find efficient paths. So dynamic programming is one of the important topic in operations research, which will be used to find the efficient paths and uses predictive pricing models to forecast fare changes. So, for example, if you click only the direct flights, you will see the set of flights. So, for example, first thing, you will have three options or four options like direct flights, one stop or two stop or three or more. So, if you say I want only direct flights, you will get a set of flights. Suppose you want to fly by, let's say, AirAsia. So, if you click AirAsia, it will be redirected to all the travel agents connected to Skyscanner. Imagine if right now in this program we have 200 students. Every one of you is a travel agent. So what is the job of a travel agent? You book the ticket for someone and you'll take a commission on that. So once I prefer to travel on one flight, the moment I finalize the flight, it will give me 200 options. For example, I'm going to name all the students in the seminar now, all the 200 as A, B, C, D, and so on, like A1, A2, and so on. So it will show me 200 different paths. It will show me 200 different paths. For example, one student, there is a name of the student is like Jyoti. So it says Jyoti Travels. It is offering you at 49,000. And there is another one, Shashank. Shashank, maybe 48,000. So it gives me 200 different paths or 200 different options. So suppose I click Shashank. It again redirects to Shashank's website. So that's how this is called the dynamic programming and the routing techniques. So that's how it works like this. So once I opt one of the, so as I already told you, all of you, everyone is a travel agent. So everyone has a specific website. So it gives me 200 options. The moment I select one option, it will take me to that particular option And again, in that particular option, suppose as I told you, I chose Shashank. Now Shashank shows me different options. Option number one, you will only book the ticket from Hyderabad to UK. Zero cancellations means if I have some unexpected situations, I will not be able to cancel the flight. Option number two, you will me as a traveler, I can book the ticket, I can cancel with a minimum charges. Option number three, I can book the ticket and I can cancel or I can reschedule without any charges. So obviously, the first one doesn't give me any options. I can only book the ticket. So if I book the ticket for 47,000, if I want to change the date, I will not be able to. So for the second option, it is giving me that I can change the travel date. So it may be 48,000. And the third one, I can change the date and I can modify my seat number as well. So it will be definitely obviously like 49 or 50,000 rupees. And again, if I opt the third one, it will give me different options again. In that, I have different types of seats: economy, premium economy, economy flex, and business class. So we initially started with Skyscanner and we shortlisted the flights. And every one of you is a travel agent. And I got option from each and every one of you. As I say, 200 students are there, 200 travel agents. And I selected one travel agent. And in the travel agent, he has three options. And in that each and every option, I have four possible seats for me now. I have to book either in economy, I have to book in premium economy, I have to book in business, or I have to book in flex. So different options. Imagine how many data sets are there. So that's how this uses data. So every flight search, it triggers like a cascade of optimization algorithms. And this system builds a massive graph of possible routes, applies dynamic pricing to find efficient paths, and use predictive pricing model to forecast fare changes. Sometimes what happens the moment I check one and I opted one, when I was about to pay, it says the seats are over. What does it mean? Obviously, many people who wants to travel from Hyderabad to UK might have opted this one and they have booked it. And the funny thing here is, if I try again and if I chose the same travel agent, the seats will be available with a different price. So which means the airline or the agency or the travel agency is tracking your need. Okay. Recently, I watched something, our needs have been tracked by different applications. Like, luckily, it's proved. It's proved. If you want to, if you try to book a cab and Uber, especially in metro cities of India, if your phone has like 95% of charging, if your phone has 95% of charging, you will see the cost of the auto or a cab, like let's say 250 rupees. But if your phone has a 10% charging, it will show you 350. Why? This is what the data-driven decision making again. Because the company wants you to pay more, because when you have only 10% charging, you will be in a stressful situation that my mobile is going to switch off. I have to take a cab and I have to leave. And this is proved in one of the European courts. And Uber got, of course, $500 million fine. So that's how your choices, your options, everything has been tracked. And based on that, companies will use them to make optimistic decisions. Again, I'm repeating the meaning of optimization: minimizing the expenses and maximizing the profit. So the one what we are discussing now, again related to Skyscanner, this is a combinatorial optimization. It's an impossibly complex set space into instant personalized results tailored to your specific preferences and constraints. So sometimes I'll give you, I will give the direct flights only. And that too, I'm not comfortable with some of the flights, but still, I will get so many other options to which uh, satisfy my constraints. So um, just look at this. This is how it calculates. We wondered like how each and everything is a mathematical model. Everything is a mathematical model. I'm I'm sure you might have, rather than being a programmer, if you are a data scientist, you will earn more money. So that's how the data science works. So our algorithms process 100 billion price calculations daily. This is what the statement of 100 billion. The population of our country is 1.4 billion, which is 140 crores, which is 1.4 billion. But the Skyscanner algorithm process 100 billion calculations daily, which means 100 times to the population of our country. So which is behind every family vacation booking, extraordinary computational power. Skyscanner's algorithms continuously analyze historical price data, seasonal patterns. Seasonal patterns. Seasonal patterns means like, for example, if you want to visit one place, there is a specific season for that. There is a specific season for that. If you want to visit US, people say visit from Feb to June. Or if you want to visit Dubai, people say November to April. So in these seasonal uh, things, the prices will be more. Why? Because of the overflow of tourists into the places. And again, competitive pricing, fuel costs, and booking velocity. Sometimes um, try to give your email ID and check something, some price, and immediately from the next hour, you will get emails that you stopped somewhere booking flights from one place to other place. The price is changing now, so start your booking process. So that's how it works. See here, the price optimization matrices will be designed like this. And the diagram, which is on the extreme right side, it shows us the different layers of combinatorial algorithms which are using in Skyscanner. Right. So this is how, I mean, the world of data is really controlling us. We are living in a data-driven world. Without, based on a survey, every human being uses Google Chrome at least 16 times a day on the planet. Imagine there are 600 crores people, and just take roughly 80% of them use 480 and times 20, which is 9,600 crores searches every single day. So every time you search, Google will track down it. Every time you search something, Google will track it. So how much data Google is? And by the way, there is something called a page rank algorithm in Google. The page rank algorithm means I'm sure everybody know the result of, all of you know the result of page rank algorithm. Let's say you're watching a news related to a movie. The next time you open Google Chrome, it will suggest to open that page also. Means whatever the pages that you are opening, Google will track down each and everything of your activity. So that page rank algorithm is also one of the applications of graph theory and linear algebra together with the combinatorial optimization. So these machine learning models predict optimal purchase timing while constraint satisfaction algorithms. Constraint means, this is a most very frequent word used in operations research. Constraint means I'm not happy with every option. I'm happy with only a little bit of options. Just like I want to go only on a direct flight, and my price limit will be maximum 45,000, like that. Okay, so that's how the world of math is influencing our decisions every single day. Not only every single day, every single minute. Sorry, every single second. That's what I want to say. So whatever you're doing is controlled. Whatever you're doing is tracked. Whatever you're watching has been observed. Whatever you're going to do, whatever you want to watch, that also optimized. So because everybody knows your data. So I'm just this is the flow of Skyscanner, the dynamic pricing algorithm, and the multi-arm bandit testing, and the graph theory route optimization, and the machine learning price prediction, and the revenue maximization. Don't think we are getting offers like freely. Okay, so everything what we are going to purchase, what we want to purchase, obviously everyone's objective is only one thing: revenue maximization. Just now I told you in Netflix, all these things will be done. They just want to create an impact on the revenue in a positive sense. In a positive sense means they want to increase the revenue. That's it. And so this is how it uses the dynamic pricing and the route optimization theory. The advanced optimization algorithms process millions of price points using elasticity models and demand forecasting mathematical functions. Um, that's what I told you, right? So you will be at the end of booking a ticket, and suddenly, when you are at the final stage, it says, "We are sorry that the ticket is sold out." This is how this happens. I mean, when you're trying to book a ticket for a flight, because they know at that particular point of time you need a ticket, and you will be willing to pay something more. So these are called pricing strategies. Okay, and with statistical significance, optimizing revenue through probabilistic models and Bayesian. Bayesian statistics is one of the important part of statistics. And when it comes to the route optimization theory, and I really don't know, but I'm expecting that most of you know it. If you just check in Google, the the flight traffic in the sky, um, you will see these many flights are there really because every single uh, point, every single airport will be considered as a point, and every point is connected to other point in such a way that there will be no collisions. So that is called the route optimization. Okay, the graph theory algorithms like um, Dikshitra's shortest path and Floyd Warshall process 1,200 plus airlines and 100,000 plus routes simultaneously. This is more important. They can process that algorithm, that optimization algorithm will process 1,200 airlines. It's not 1,200. One airline operates thousands of flights. Um, Recently, when it comes to the Indigo problem, Indigo has only 380 flights, but it operates nearly 2,900 services every day. Means one flight will go 3 to 4 times or 5 times or 6 times every day. So that multiply 12, that is one airline and 1,200 airlines and 100,000 plus routes simultaneously, such that there will be no collision, no contrast like that. These mathematical models consider they have, I mean, these data sets, again, they have different variables like distance, fuel cost, demand patterns, and time constraints to optimize flight recommendations for users. But this is another example. Uh, there are like, so see here, the route optimization, and this is what the processing distribution, and this is a graph theory algorithm. It reduces the search time by 75% while processing millions of route combinations in real time through optimized mathematical computations. So this sophisticated mathematical model of Skyscanner processed over 2.5 billion flight searches monthly. Oh my God. 2.5 billion flight searches. So just imagine how much data will be there. And each and every data has to be modeled with a mathematical model, has to be cleaned with some program, and use some statistical model to get a maximum benefit out of that. So this is how both, all mathematics, statistics, and computer science works together, and they form data science. And so this is another example, especially in banking. In banking, mainly the probability, Bayesian statistics, and machine learning works a lot. The modern banking relies on advanced probability theory. In one sense, for example, if you're applying for a loan of like 10 lakhs, and I'm the bank manager, and so I will estimate the probability. This guy, the probability that the loan will be repaid properly is 80%. Then only I will give the loan. If I get any doubt that the probability for repaying the loan is 49%, which means 51% will be the failure rate, obviously I will reject your loan application. So every operation of banking is applied on a probability theory. Like what I told you is just in a minimum sense. And the statistical modeling will be done to assess the credit risk and detect the fraud and predict the market movements. These institutions employ teams of quantitative analysts who build mathematical models using stochastic calculus, time series analysis, and machine learning to quantify and set. Time series is just like you can say in a very normal sense, the value of a one commodity is like this from the last 20 years. What will be the value in the future? So this is one. I'm just giving you a small sentenceable example. And machine learning to quantify uncertainty, the mathematics transactions, historical patterns into forward-looking risk assessments, and protecting billions in assets. So this is how we use data and mathematical models and programming techniques, and then we use these things. So now look at here. If I want to summarize, this is how the three examples what we discussed. See, look at here. The Netflix recommendation matrix is like this. So these applications serve different purposes. They share common mathematical foundations. As I told you, linear algebra powers Netflix matrix factorization. Graph theory and optimization drives Skyscanner's route pricing, route finding, and probability and statistics enable banking risk modules. And all the common thing we need, all these is the mathematical modeling, collecting the data, cleaning the data, apply a statistical technique through a program, which is related to computer science, and take an optimistic decision, which will help the organization to maximize the profit. So together, the mathematical disciplines from the invisible infrastructure of modern digital economy and processing huge bytes of data daily to create seamless user experiences. So somehow I felt these three are the most relevant examples to explain about the data science. So, so that's see, this is how the roadmap for data science and mathematics. So the linear algebra plus statistics and calculus will be the key formula for the modern miracle of technological advancement. So these three mathematical disciplines developed over centuries. We know that, right? And you people and are definitely doing these courses now. So give your full effort and try to work in this area. It'll be really good for you. So this is what my last sentence, which will be useful for you. That is the future is mathematical. So maybe you might say that I'm okay with as a software programmer. Those days are gone. So unless and until you develop a specific skill, uh, which is related to a proper scientific methodology, it will be very difficult for you to excel. So this is how the data scientists and mathematicians, they're writing the equations, they develop the models, and they're trying to shape the humanities' technological revolutions by transforming pure mathematical theory into tools that will define our collective future. So this is how the data science is the new evaluating area where mathematics, statistics, and computer science together are using for the technological advancement. So that's it with my presentation. So that's it. So I think I'm done.
Okay. Thank you, Kumar, for your wonderful lecture. Very interesting.
Yes, sir. Yes, sir.
Kumar Garu, really wonderful lecture.
Thank you, sir.
So it is really useful to our students.
Thank you, sir.
Okay, thank you, Kumar Garu, for your lecture on mathematics behind data science, the secret engine of today's tech innovations. Okay. This is the time for question and answer session. Because of the huge participants, any participant who is interested to clarify his or her doubts, please come forward to post it only in the question and answer box. Sir will clarify the same. Once again, participants are requested to post their queries in the Q&A box if any. Sir, if we can go for a vote of thanks, sir.
Okay, sir.
Okay. So thank you one and all for your good response and valuable support. Expecting the same cooperation for the remaining sessions also. Our today's session concludes with vote of thanks by Staff Coordinator Sri I. Potraj Garu.
Kumar
Good evening
Garu,
to all. On
Potraj
behalf
Garu
of the
also
Department of
is-
Mathematics and the participants, I would like to express my heartfelt thanks to our today's resource person, Sri NVRD Kumar Garu, Senior Faculty, Department of General Education, Harjan University College, Emirate of Esman, United Arab Emirates, who gave such a good and informative presentation on mathematics behind data science, the secret engine of today's tech innovations. Despite of his busy work schedule, he gladly accepted our invitation and gave a valuable talk in today's session. Thank you very much, sir. I would like to thank our beloved head of the department and convener of this international workshop, Dr. KVLN Acharyulu sir, who guided, motivated and supported us to do this program and encouraged us to shape out today's program. I would like to thank our principal madam and our management, Bapatla Education Society, for providing us all the facilities and encouraging us to conduct this program. Without their support, it would not be possible to conduct such a program today. I would also like to thank Dr. K. Mandip Garu, HOD Department of AML, Sri N. Kiran Kumar Garu, MCA HOD, Sri Koteswarao Garu, Faculty of MC Department, and Sri U. Venugopal Garu, who are sincerely extending their technical support to us in conducting this international workshop. Thank you, Ananda.
Thank you, Potraj. Before going to close the session, a request to all the students. We are going to share the feedback link in WhatsApp group. All of you, please fill the feedback immediately and
Kumar
attend
Garu.
all the sessions from tomorrow and day after tomorrow. Okay.
Kumar
Thank you,
Garu.
Ananda.
Yes, sir.
Kumar Garu.
Yes, sir.
Kumar Garu, kindly extend the same cooperation and valuable support in future also.
Thank you, sir. Sure, sir.
Thank
It's a
you,
pleasure.
Kumar. Thank
It's
you.
a pleasure, sir. Thank you.
Thank you, dear.
Thank you, sir. Thank you.
So
Thank
we'll
you,
meet
sir.
later. Thank you.
Okay, sir. Thank you.
Bye.
All the best, Kumar.
Sir, I'm closing the session, sir. Okay.
Sir, question. Sir,
ఉంటావా?
meeting